Hello again, and today the video is about solving a linear equation, but it's a little bit hard. Okay, yeah, challenges. We love challenges, right? So what is the equation I write here, but I will rewrite, okay, so that you see what is. This is the equation as plus s divided by 1 plus 2 plus s divided by 1 plus 2 plus 3. As I'm writing up to here, you can see the pattern, okay? Yeah, mathematics is about the pattern, because actually the first term is s divided by 1, and then the second term is s divided by 1 plus 2, and then of course you know the next term should be s divided by 1 plus 2 plus 3 plus 4, and then after that we get lazy, okay? So that's why mathematician invented these 3 dots, okay, to say that okay, we skip terms and we give you only the final term, so because you already understand the pattern. Is this the correct? Yeah, I hope that is correct. So via this problem, okay, I introduce to you the 3 dots, okay, because mathematicians are lazy. They just give you a few hints and then you recognize the pattern, then they put the 3 dots, okay? That's one thing you learn from this video. The second thing is this is not an easy equation, but this is something you familiar with, because it has only s. Okay, it has only s. It means that you can factor out s, okay, and here you have 1 plus 2, 1 over 1 plus 2 plus 3, blah blah blah, up unto 1 plus 2, blah blah blah, up to, and this is equal to, okay, whatever it is, and we hope this guy in the brackets is a number. So actually this scary looking equation is just as equal to, so s divided by a, of course a is not 0, so I can divide it. Yeah, if you stop here, and then you can get out of 10. If I'm a teacher, out of 10 I would give you 6. I would give you 6, because this is a very good plan, you know. It's a very good plan that you know this is a linear equation, and linear equation always has this form: a equal to s, as equals to b, right? So s is b over a. So you recognize that. So I would give you this, but of course the whole question is about evaluating this sum, okay? I don't know why they don't ask you just evaluate this sum, why you have to put it into an equation. But anyway, I don't remember where I got this question. It must be in any exam in a city or a country in a year. Okay, now the problem becomes compute. This color is not so nice. A 1 plus 2, 1 plus 2 plus 3, looks very scary, okay, because you have the dot here, so many terms. So how many terms it has? From 1 to this, more than 4,000 terms, right? And then you have another dot here, so it looks scary. But and they are asking you to do it maybe within 20 minutes or so, because it is just one question in exam, so it has to be a secret or a pattern here, okay? So you can try is go on and go on over 3, right? 1 plus 2 is 3, and 1 plus 2 plus 3 is 6. And then you can guess the next number is 1 plus 2 plus 3 plus 4, right? Is 10, right? Blah, 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 blah. I don't write the final, okay? So go on. So what is special? Now you ask question, right? Because you have to observe. So what is special about 1, 3, 6, 10? Has to be something special about that. It's very interesting here. Of course, from here there are two ways to proceed. If you know, then it's easy. But I am trying to follow the way that you don't know. You don't know that there's secret between behind these numbers. Okay, so that's why I'm trying to. Okay, so you imagine that 1 is a rock. Okay, a rock. This is 1, right? And then what 3? 3 is, no, I should put 1 here. 3, right? That's 3. And how about 6? How about this is 3? How about this is 6? Oh, sorry, this is 3, this is 6, and then next is 10. Now you can see the pattern. 4 rocks. I can use bigger one. What is the bigger one? Oh no, just 3, and then 4, 3, 2, 1. So now you see they all make, except the first one, they all make the triangle. You see, they all make the triangle. They make the triangle. That's why they are called 1, 3, 6, 10, and 15, and etc. are called triangular numbers. Okay. And if they are triangular numbers, then there is a formula to write it down. The triangular, the end triangular. This is the first, the second, the third, the fourth. Okay. So this is T1, this is T2, and this is T3. And this is T4. Okay, so T4 is 10, T3 is 6. So what I'm saying is that there's a formula for that, and Gauss, okay, the great German mathematicians, gave us this the formula. So his idea might be, okay, he was only 10 years old, is put another triangle. Okay, so you put another triangle here. Exactly the same. What? Oh my god. What is terrible that? Okay. Sorry about that. Let me continue. You put another triangle. 1, 2, 1, 2, 3, and 4. 3. And then 2, and then 1. Okay, this is another triangle. It's exactly the same. You see, 4, 3, 2, 1, and then if you sum them up, how many dots you get? 1, 2, 3, 4, 5. 1, 2, 3, 4. So you get 5 times 4. Okay, this is the total, but you have to divide it by 2 to get the rocks of one triangle. So the formula here is n plus 1 divided by 2. Okay, it means that 1 over 6, I just take one number here, I can write it down like this, because 6 is T3, 6 is T3, and 6 is T3, it means n is 3, so it's equal to 3 times 4 divided by 2. So 1 over that is 2 3 by 4. Okay, and then now I can rewrite 1 plus 1 over 3 is similar, is 2 over 2 times 3. Okay, 2 times 3, 2 3 times 4. Now you can see 2 4 times 5 plus 2 divided by, this is the final one. The final one is n is this number. Okay, so it's this number times this number plus 1. Yeah, this is the triangular number 4021. Okay, this is 1 2 3 4 up to that. That's it. And then what can we do? We put 2 out. Okay, we put 2 out, factor it out. Right. 2 times 3, 3 times 4, blah blah blah, and I can put the times. Sorry about that. It's no problem. So what's the point of doing all of this? Okay, the point is that now if you look at this guy and this guy, this guy and this guy, what is special about them? Their difference is 1. Their difference is 1. Their difference is 1. It means that this guy is equal to see, because their difference is 1, and this guy 1 over 3 4 is, yeah, multiply by this by 4 by 3, and then you have 12. You see, now A has a very nice pattern. Is 1 over 2 minus, and then 1 over 3 minus 1 over 4. Of course, next term is 1 over 4 minus 1 over 5 plus 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 plus, and then 1 over minus 1 over, and before that term, okay, I will write out the term before that is 1. You see 2 3 3 4 4 5, so before this it should be you see, you can imagine 4 5 5 4 4 3, then 4022 4021, then this is should be 4021. Now this term is very there is, let's make this a squared, and then I should have a square bracket here, sorry about that. Now this sum is special because you have minus 1/3 and then you have plus 1/3. They cancel each other, and similarly where I'm have a British accent, is weird. 1 over 4 minus and another 1 over 4, so is 1. And then I use a different color. 1 over 5 minus 1, you don't see it, but the next term you see it, okay? And then you have minus 1 minus 1 over 4021, and then you have this. So everything is gone except the first and the last. Okay, if you still not clear, you can write this way, okay? 1 over 3, this is the first, and then the next is, and then the next is, and then the next is. Okay, you can stop here, and then you sum them up. You see diagonal, you have this line, only the first and the last. Okay, now out A has more terms, that's why it's like this. So A is nothing but 1 plus 2 times 1/2 minus 1 . Okay, so this is I have to do. So I have to multiply this by 2 0 2 2, yeah, and then minus 1 1 plus 2, this is 2010, and then this is 2011 times 2, and then this and this gone, okay, and then I put 2011 plus 2010 over 2011, so it's 2011, and then 4021, this is A, and then the solution, because they're asking for this, is here. S is 4021 divided by A. 0 2 1 divided by a is multiplied by the let's do it here, 2 1 multiplied by the inverse. So this guy go up. So the solution is 2011. Oh. Whew. So let's now do the self-reflection. Okay, what did you learn after solving this this problem? Okay, so first thing is that this is just a linear. So the first thing, even though it looks messy, it's just a linear equation. Okay, so it has this form, and linear equation has only one solution, right? Because I can draw this line. This is a line, right? You learn from René Descartes. Is this line, and then it intersects the x-axis at only one point, so have one solution. What they wanted your life to be challenged. Okay, that's why the coefficient a here is very complicated. It's 1 plus 1 over 2 plus 1 over 2 plus 3 plus up to complicated. Okay, because if a is just from here to here, then it's like humiliating you, right? So they has to challenge you. So this sum is interesting because on the numbers in the denominator, on this number in the denominator, they are triangular numbers. Okay, triangular numbers. The first is that, the second is this triangle, the third triangular number is 6, the next is 3 2 1. You see, they make a triangle number, and triangular numbers, we can have a formula for that. Okay, so this is, they call it Tn, T for triangle, and n is, this is n1 and 2 and 3 and 4. The formula is n plus 2. Yeah, if you plug in 4 here, 4 5 is 10, 4 3 is 7, 9, 2 is 9, and then 10. You see, so because of that, so here you have 1 over Tn, right? I'm talking about the n term in this, so you can convert it. And then because n and n plus 1 is 2, 1 over n minus 1. You see? Yeah, because of that you can write this, and because we can write this, you have a sum of differences. Okay, this is a sum of differences. So a is a sum of differences because it has this form. Okay, I just writing down 3 terms, but you see this is a difference. This is another difference because it's minus here. This is called a sum of differences. And what is special is that if there's minus here, there's a plus here. So gone, 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 gone. This is called a telescope sum. Okay. Did you watch a movie on pirate? You see the telescope, right? Because you can expand it. This is the expand form, and then you can collapse it. The collapse is that you just have this, the first and the last. That's called, mathematicians call it a telescoping sum, or telescope, should be telescoping sum. Okay, and it appears again and again in mathematics. Okay, so the person who designed this question, actually they only testing me, for example, who already knew about telescoping sum. If you don't know this telescoping sum, how can you know that this nightmare's expanded lengthy sum can be collapsed into a very nice form? You cannot, unless you're a genius. Okay, I'm talking about the majority here. So this question to me is not a good question. This is just that's either you know or you don't know. So it's very unfair for people who unfortunately don't know this technique before the test, because how can they solve it unless you are ghosts? But we don't have many ghosts, don't we? So this is not a good exam. But anyway, this video introduced you to the 3 dots. Okay, when we need to use that. Okay, because when we already see the pattern, we don't have to waste time, right in the next term, because it's a lot of time and space. Okay, so we just write a few terms to demonstrate the pattern, and then dot. Okay, that's one thing. So the second thing is that I introduced you to triangular numbers, you see, and this is to show you that there's a strong connection between algebra and geometry. This is something that not emphasized in the in the school curriculum. Okay, you see, 1 3 5 1 3 6 10, and then you have triangles. And why, when you link numbers with shapes, with triangles, why is it help you to better understand the numbers? Because with shapes you have something tangible, something you can touch, something you can draw. And then by drawing this triangle, right, this is a triangle. I don't know, I think we prefer square, right, because it's or rectangle. So we draw another one, and then by that you happen to discover the formula for triangle. It means that you can compute this sum. And after that, this is something that you have to learn, is that if you have a sum and one term has this form, let's make it one. You have many terms, okay? You have many terms before and like that, and you want to compute this sum. Of course, you want to cancel terms, right? And that's why you write down at this, okay? Because then you can cancel, because they're minus here, and you can cancel. Okay? So here you split this one into this form. This is a technique that you have to know. if you want to do mathematics. Okay, so there's so many techniques. Sometimes this term we do this because sometimes this happens. Okay, now you learn another technique is to split this into this. Okay, what I'm trying here to say, of course, want to do mathematics, you have to learn a lot of techniques like this, but below this techniques is the principle. The principle is that anything has many faces. Okay, this is one face and here is another face. Okay, I'm saying that because I have just watched the movie, my favorite movie, Primal Fear by Richard Gere. Okay, my favorite actor. And the bishop in this movie, the one who was murdered, has many faces. Okay, to the public he is the great bishop, but behind the doors, okay, in his church, he's an evil. Okay, of course this is up to him, that's his life, but I want to say that mathematics is like life. The object in mathematics has many forms. Okay, many forms. So I show you here one example. If you want, if you know, if you learn in trigonometry, so you have a right triangle, right? And this is A, this is the A, this is B, this is C, this angle is S, then side is opposite, so AC. This is to say that this is the length, the measure of the length of the size AC divided by BC, right? We all know this. If we okay, but to Euler, no, to Euler, this is psi. Euler, this is psi. I hope that I write it correct. 135 plus minus blah blah blah. Okay, so you see this is one form of the size and this is another form. This is the same sign. Yeah, and similarly sometimes you use this one, but sometimes you use this one. So the more you know about mathematics, these secrets of the mathematical objects, the more you can understand them. It's just like how to deal with people. Okay. So I hope that that's it for the second video. Okay. I have to talk to mention about my English. I am Vietnamese and I grew up in Vietnam up until I was 26 years old, and then I left for France. So my English, I don't have any accent, okay, or maybe Vietnamese accents, that's fine with me, I don't care about that. But I don't know, because I watch many movies, Hollywood movies, you know, sometimes I take the accent from an American actress, or sometimes British accent, so please forgive me, okay, about that. And of course, my speaking English is not perfect. I know with some difficult sound, I cannot speak it well, and sometimes I put an S where it should not be there. But this is more about mathematics, and I hope that I was helpful. Again, if you like what I'm doing here, please subscribe to the channel and share, and give me comments on what you want me to talk about. I can do anything up to university level mathematics. Okay, more on applied mathematics, not going into very like professional mathematics. Okay, Anyway, goodbye and see you again.